Provost, Dean, thank you for their very kind introduction. Maria, thank you very much for imparting those particular pieces of information. I'd like to start by introducing you to the diary of Mark Little, aged 12 3/4. This was discovered upon a move, when packing everything up to move back to Dublin back in 2012. And it's clear that I was transfixed at that time with measurements and predictions, as evidenced here by the degrees of luckiness scale, which was established apparently by the daily roll of a dice. My dice was loaded because the average each month was always over 3. So it's clear that for me, it's always been about the data. Indeed, the variability between these months tempted me to try and predict what was going to happen. And there's actually a faint pencil line there that I try to predict what's going to happen with the dice rolls. Clearly I got it wrong, but we do stand at a unique time in history where we have the availability of data science tools that give us unprecedented opportunities to have deep learning about the social and biological processes that shape our lives and shape our world. So this is a story about my journey towards Bayesian statistics and, and artificial intelligence. But I must introduce my adversary for the last 20 years, autoimmune ankylosing, and a date, April 3rd, 2015. This was a very important date for Donald, we'll call him, it's not his real name. And we'll refer to him thereafter as 2236, this is the number from his RKD registry, his ID. He came to hospital on that day with a rash that developed rapidly and started rising up his legs. In addition, he had shortness of breath and started to cough up a little bit of blood. Now, the appearance of this rash was due to bleeding within his skin, and the presence of blood within his airways, and when he was coughing it up, was due to bleeding into his lungs. He required a ventilator to keep him alive at this point, and his kidneys subsequently failed. The doctors who were looking after him stuck a large needle into his back and took a little piece of tissue, and this is what it looks like. This is a glomerulus. I was told not to use the word glomerulus, but I'll have to use it because I've studied them all my life. These are the little filters in your kidneys. You've got about 1 million in each kidney. And this little area here is normal. The rest of it has been destroyed and replaced by an inflammatory mass of cells. One of the main ones being a white blood cell called the macrophage, which is shown here in brown. Now, this man has presented with a multi-system disorder affecting his skin, his lungs, and his kidneys. And the first clue, really, that this was not, his immune system was not reacting to some microorganism, but actually to a protein of his own body, was the presence of an antibody in his blood called ANCA. Now, ANCA is an antibody that requires its name, anti-neutrophil cytoplasm antibodies, because of the way that it binds to the most popular or the most common cell in your blood, the neutrophil. And this is a picture you might see if you put neutrophils and the patient's blood into a test tube together. We now know, of course, that these antibodies are directed against one of two particular proteins. First of all, these proteinase 3, for short PR3, and myeloperoxidase, MPO. And a lot of you may know MPO because of the green color of your sputum when you have a chest infection. That is due to MPO, which is bright green. Now, 2236 was very unlucky because he was struck down by a very rare disease, of which there are only about 50 or 60 cases a year in the country. This makes it very challenging to study as a disease because we don't have access to large numbers of samples or clinical data. But in looking after patients like 2236, I have come to have two big questions that I really try to answer with my research. The first of these is 62 years this man has been walking around, and he's been living with his MPO for all that time, and suddenly, out of the blue, at the age of 62, he suddenly develops an immune reaction, immune dysfunction that attacks his own cells. So what has caused his immune system to suddenly destroy his own blood vessels at this point? Is it something that he's met in his environment, an infection, or something else? And secondly, how do we restore this immune system to balance so that 2236 can thrive and manage without immunosuppression, so that the antibody, the ANCA, disappears, but the rest of his immune system is left intact so that he can fight infections and cancer. A little bit about my early days in Dublin in the 90s. I am a nephrologist, which means that I delight in studying and playing with urine. I'm also a clinician scientist, which means that I have a foot in the clinical and the scientific arena, which allows me to have first-hand views on the clinical challenges that cause adverse health. Now, there were three people who were instrumental to my early decisions regarding nephrology: Michael Carmody, John Donoghue, and Joseph Walsh, who I'm happy to say is here in the audience. They introduced me to the data science, or the data-driven specialty of nephrology with its graphs and measurements, and laid the path for me to study these little black things in the kidney, which are, of course, the glomeruli. And this path led me to the UK, the wonderful NHS for 14 years. And I'd really like to acknowledge three people, as mentioned by Professor McCarran already. First is Professor Charles Pusey from Imperial College in Hammersmith, who introduced me to the intricacies of ANCA during the course of my PhD. Secondly, Caroline Savage, who helped me bridge that difficult gap between postdoctoral fellowship and independent scientist. And thirdly, my partner in crime in UCL, the Royal Free Hospital, Alan Salama, a font of brilliant ideas and a really trusted sounding board. Now, my early investigations into ANCA vasculitis really focused on the effect that the antibody has on the white blood cell, what molecular events happen within the cell when the cell attacks the neutrophil. And for example, in this case, when you immunize with myeloperoxidase and raise antibodies to it, and this real-time intravital microscopy video of a small blood vessel, as you can see that cells are sticking, these white blood cells are sticking and migrating through the blood vessel wall, and on occasion, in fact, causing blood vessel destruction, reduction in blood flow through that little blood vessel in the bottom left, and bleeding in and around the tissue. And this is the same process that has caused the bleeding into the lungs and the feet that I showed you. Now, I returned in 2012, as Professor McCarran mentioned. I was very lucky when I came back to be awarded the Science Foundation Ireland President of Ireland Young Researcher Award, which provided the resource to allow me to set up my own independent research group. Now, during that time, I became a little grayer of temple. I went through 5 Movembers, and all the time I watched Professor McCarran's eyes narrow as the time to my first inaugural lecture became longer and longer. But I'm delighted to say that it finally came around. I had the opportunity at that time to establish the Trinity Health Kidney Centre with support from my colleagues, and I'd really like to acknowledge here the support of Tala Hospital, and also Peter Lavin, Catherine Wall, George Mallet, and Brenda Griffin, and also of Peter Conlon from Beaumont Hospital. One of the infrastructures we established during this time that helps us to address some of the big problems that we want to study in ANCA vasculitis is the Rare Kidney Disease Registry and Biobanks. It's funded by Science Foundation Ireland. And because each individual hospital really has very few cases, we took the view that we need to enlist the help and the grace and favour, really, of lots of consultants and junior doctors, too many to mention here, to study this disease across the whole of the country. And this has allowed us to accumulate or recruit over 600 patients with ANCA-vasculitis, along with their clinical data and their linked clinical samples. Now, one of these recruits is 2236, and he was kind enough to agree to give us his clinical samples and his clinical data. Now, he did quite well after his initial presentation, treated with heavy-duty immunosuppression, and managed to recover his kidney function so that he didn't need dialysis anymore. And he did okay between then and now, despite having to take ongoing immunosuppression drugs, because this disease has a penchant for coming back. Now, this happened until February of 2017, when he became unwell again. Again, he became short of breath. He'd lost a little bit of weight. He had some joint pains. There was a slight change in his kidney function, and there was a little bit of blood and protein on his urine in the dipstick. Now, the normal state of affairs when this happens is that we do another kidney biopsy, stick a needle in the back, to have a look and see what the tissue showed. Now, the presence or the access to over 600 patients with serial samples and data has allowed us to study a specific protein. This is one of a couple that we've studied, but this is what I'm going to focus on. It's a CD163. This up here is a normal glomerulus with very little staining of CD163, which is in brown. This is a glomerulus with early ANCA-vasculitis with a few cells staining positively with the protein. And this is the one we saw previously, which is full-blown ANCA-vasculitis causing the kidney destruction and loss of kidney function. And interestingly, the protein disappears as the disease is treated and is not seen anymore when the disease gets into remission. So this is the kidney biopsy of 2236. And what struck me really was that this brown area here was in direct communication with the white area, which becomes urine. And it led me to wonder whether measuring this protein in the urine would actually give us a window onto the glomerulus and tell us what the load of these brown staining macrophages might be. Now, needless to say, this is what we found, this is what we discovered. And this is the measurement of CD163 in the urine. These are patients who have kindly been recruited to the Rare Kidney Disease Biobank. And these groups here, these are patients who have active kidney vasculitis at the time of the urine sample. These have active vasculitis but not in the kidney. And both of these groups are in remission. Now, you can see here is that the level of CD163 in these three groups is virtually undetectable, whereas there's a very high level in the patients with active vasculitis. Now, it's very important with these scientific results to validate them in another cohort, again provided by the Rare Kidney Disease Biobank. And so this validation cohort again showed virtually identical findings. Now, when we tried to publish this, even though it was already the biggest biomarker study in vasculitis, they said, well, we need another validation cohort. So we went back to the biobank again, and another set of patients, we analysed their urine and found exactly the same thing. Now, it is important when we have a discovery like this that you go to a completely independent place. So we contacted our friends in Groningen and asked them to measure CD163 in the urine, and they found the identical finding. Now, this is all of the samples that we've measured with CD163, and each one of those little circles there is an individual recruit. Again, we see that the levels are very low in healthy people and in remission vasculitis and high with active disease. And this was a sample that was provided by 2236 when he presented again in February of 2017 with a little bit of a change in his kidney function. So the question really is whether, if we'd known this value at that time, which we didn't, could we have avoided doing that kidney biopsy? And it is on that basis that we were able to license this technology to a German company called Euroimmun, who have developed a kit, quite a rare event to happen for a basic science finding, to be translated actually into a clinical test that hopefully can help people improve their management of patients around the world with ANCA-vasculitis and other forms of glomerulonephritis too. Now, I've found all the way along this path that trying to do things in isolation doesn't really advance you towards your goal very much, and that you really need to make friends, particularly with people who have different skills from you. So we have brought what we've learned from setting up the biobank to establish, first of all, a local network if you like, here in Telehospital called the Televasculitis and Allergy Group with help with Stephen Lane. And it's a clinical group that gets various people together to help improve the care pathway for patients with bizarre, rare immune disorders such as ankylosing. This has led into establishment of a national network called the Vasculitis Ireland Network, VINE, in collaboration with colleagues from some other hospitals in Dublin, including St. Vincent's and St. James's, from Cork, from Galway and from Northern Ireland. And I really must acknowledge here the input of the patient group, Vasculitis Ireland Awareness, who have stood beside us all the way along this path, informing our research choices and ensuring that the patient is at the centre of all of the research that we do. So panning a little further out, I and other colleagues have established UKIVAS, which is the UK and Ireland Vasculitis Group, which runs a very large registry, which recently surpassed 6,000 recruits over 67 sites in the UK and Ireland, making it by far the largest collection of data for vasculitis in the world. So learning from these, we have tried to apply this at a European level, particularly under the auspices of the European Vasculitis Study Group called UVAS. I've attempted to amalgamate all of the registries across Europe, and with the Helical Consortium, which seeks to ethically link clinical data with research science findings at a European level. Now, applying these networking attempts, we have tried to spread this out a little bit further to patients with all rare immune disorders. And with colleagues in Newcastle and Munich, we successfully applied to the EU for the creation of the RITA Rare Immune Disorders European Reference Network. And what this does is provide people with access to expert care for these rare disorders all across Europe, no matter where they are, often via video link, because it is really not practical to have experts in these diseases in every city. Now, a lot of my career I have studied individual genes and proteins from a molecular biology point of view, and this has been likened to a street where you are examining the ground under a pool of light. And I've often been fascinated by what is also on the street when you turn the lights on, and what are the things, if you're studying a disease in a patient, what are the things you might learn by studying the patient in the entire context of their environment. And one of the inspirations for this for me was the Cloudy with a Chance of Pain study from Manchester, which rapidly recruited 15,000 people, and using their smartphones and using the GPS in their smartphones to ask the question as to whether the pain that they feel in their bones is truly due to the weather. And because people entered pain data into their phones, they were able to triangulate and link that to the weather data by the GPS in their phone. This is not reported yet, but apparently there is no link between weather. Don't quote me on that, but there's no link between weather and pain in your bones. So I have kind of wondered, based on that, whether if I knew everything about all of the patients in the biobank at all times, would I be able to study their diseases and gain new insights into what's happening to their immune system? I'm also interested as to whether that statement makes anybody nervous in the room, bearing in mind, of course, that Amazon, Google, and Facebook are all doing this to you anyway. But there are clearly ethical implications there, and it is by creating a partnership with Vasculitis Ireland Awareness and patient groups that we have created a trust, if you like, between us, and we have asked whether would we mind if we do that kind of thing, and they have agreed to help us do it. So we have kind of determined that 2236 in February 2017, on the basis of a kidney biopsy, had a flare of his disease. And so what we're interested in now knowing is what triggered that flare? What was that thing that happened? Was it the same thing that triggered his disease initially? We'll never know that because we don't know about him before he was diagnosed. But we know who he is now, and we can track him through space and time and work out whether there are some triggers for this flare. And the key to this, of course, is the smartphone. And this allows us to obtain location through the use of GPS, activity data from the accelerometer in the phone, and also self-reported feeling. How do you feel at this current time? It's a simple questionnaires. We also have the opportunity to link that data with the data from the biobank and registry, which I've told you about, and also bringing all these huge, diverse data sources together. There's no way in the world that I would be able to do that. But people in the ADAPT Centre and the School of Statistics and Computer Science in Trinity, there are individuals there who actually can do it. So that's the basis of the Chronic Disease Informatics Group. So what happened? I'm interested in knowing what happened along this path that triggered a flare of vasculitis in this in 2236. Was it something in the weather? Was it something in pollution? Was it something, an infection of some description? Now, there are granular online time and location-specific data available for download now by anybody that can help you to triangulate this flare event and see whether there are patterns in people who have had flare. About 50% of people in the whole biobank will have a flare. Whether they are different or their exposures have been different to those who did not have a flare. And bringing this all together is really the domain of the ADAPT Centre and the statisticians in Trinity. And there are lots of different ways of analysing this data, most of which is unintelligible to me. But a lot of it is based around Bayesian statistics and artificial intelligence, which is quite kind of buzzword at the moment. And again, there are lots of different ways of doing artificial intelligence. This is just one neural nets. And the beauty, I think, of artificial intelligence is that because we have rare events, there are not many things to study, but each one that comes on, the system can learn. So with each new event, we can get more defined algorithms that help us predict whether the person will have a flare event within the next 3 months. And that's our end game really here. That's our goal. This is our computers and the kind of nominal computer screen. On the left here, we have some standard measures that doctors use to help them predict or guess, really, what the risk of flare is down the line. There's a couple of novel ones here, like our CD163. And on the right-hand side here, we're integrating the data from our environmental studies and from the app-derived patient-reported outcome measures. And putting all these together, deriving algorithms that give us a numerical value and a dashboard that tells us whether there's high risk, medium risk, or low risk of a flare in 3 months' time. And that, we hope, will help the doctor to decide whether to stop the drugs, increase the drugs, or leave them about the same. So, to finish with, how have my degrees of luckiness panned out over the last 20 or 30 years? Well, I've been very lucky over the path to work with a wide range of fantastic people, not least my current research group in the Trinity Translational Medicine Institute, and along with a couple of prior members who have been really important in developing the research as we go. In the Chronic Disease Informatics Group, doing that fiendishly difficult data science that will help us to answer those questions with regard to the effect of the environment on triggering of autoimmune disease. The funders, of course, nothing would happen without them. Science Foundation Ireland, Health Research Board, Vasculitis Foundation, the Meath Foundation here in Tala Hospital have all been really important to developing this. But of course, most of all, to my family, and particularly to my parents, without whom I would not be here at the moment, obviously, but who have made me really who I am today. And to my sister Cass, who has been an inspiration all the way down the line. And of course, to my wonderful wife, Maria, who gave up so much to come back to Dublin and to support me in my move back to a chair in Trinity, and who really carries the weight of our family on her shoulders. And to my two little monkeys, Sarah and Maggie, and I will leave you to meditate upon your data and who's looking at it now. Thank you very much.